Good morning. Good morning, everybody. Namaskar. This is Engineer Suraj Singh speaking from Bharat, India. On this day, January 30, सूरज सिंह सिविल इंजीनियर भारत इंडिया से बोल रहा हूँ। आज जनवरी 30, 2022 रविवार 3:51 सुबह के 30 जनवरी 30th जनवरी day on which Mahatma Gandhi, or you can say Mohandas Karamchand Gandhi, leader of Congress in 1948, was assassinated by Godse, Nathuram Godse. And we remember millions of our people who laid their lives in freedom struggle. This is a condoling day. Gandhi was assassinated by Godse, right with Hindu people, person, a misled citizen of this country who had no right to kill anyone, but he killed leader of freedom fighting struggle, one of various leaders like Subhash Nehru, Gandhi, and many others. All people of this country were dipped into condoling in sorrow on this day. Martyr Day we call it. It is very bad that somebody killed a leader who struggled a lot, and in fact that Godse did not kill Mahatma Gandhi. That person killed sentiments of Bharat, India, sentiments, real sentiments, and there are some people who support him, and I call them foolish people, mindless people, heartless people who find out business in every art. Full day for me as well as for everyone who is Bharatvasi, Indian. We should not support such killers and those who support such killers. Whoever they are, wherever they are, they have no right to support any criminal. If somebody kills someone, nothing but top class criminal I can say, and because that person killed humanity, that we can call a terrorist. Those who support such criminals, whether or not it was justified or it was not justified, it's a different issue. But who are you to kill someone? That is one point. I'm talking about quality. Just the reference is given about 30th day of January 2022 because of reference to 30th January 1948. Gandhi was a freedom leader, and before Gandhi there were so many freedom leaders. I'm not naming anyone. Everyone was leader. Whole population of this country was leader. And it's really unfortunate this happened. In words of Nehru, light had gone out at that time. He said, light has gone out. And that light illumined us for leading movement to get, to catch, to arrest independence of our nation. And again today, I remember because in 1955 I got entry into this world. '68th birthday also. Just for information, so my birthday is a day when some assassination was done. Well, come back to original work, original talk. Signals are falling badly. it happens. Frame per second is also too low. And this is my file. Here you have seen about my email ID address, suraj_engineer@yahoo.co.uk, and that is certification as Professional Engineer International, and this certification is Chartered Engineer India, and this certification is Fellow Member of Institution of India, and this file is about quality that Bharat India speaks, and other files too I'll relate to. So I say just a review of. We come back to same talk. I consider these files and these certificates, and we stick to this file, and I close this FI certificate here, and I also close this file CE, and come to quality issue, and that is Bharat India. Bharat India, which is my country, your country, and title of talk is Quality Works. Quality Works. Concrete specifications, civil field engineering, life engineers, and we know quality system related AnnexSL and contract related pages or books, red, silver, white, and of course safety, health, and environment related issues, designs, construction, methods, contracts, disputes, organizations, communications, coordinations. Just for your reference, I write many postings on Facebook and link them to LinkedIn as well as to SAFE about safety, health and environment, about project management, or you can say about method statements, how to work on sites, and many other topics. Every day, some postings I do, those are supportive. Currently, I have been undergoing safety, health and environment postings, and I did method statement posting before, and facilities postings, of course. Those are all related to same talk, but this is video daily, or you can say so many topics are covered within this video, because these topics are all linked somewhere with each other. Therefore, exclusively to take out one topic and discuss is not right way, so I put them together in a coordinated fashion as we start quality works rather than quality alone. I amended it. Before I used to prefer quality only, but quality only doesn't work if you don't consider works. Quality of system is important, but if system on its own cannot work, if people are not interested, if people are careless, if they don't take interest in such issues which are very important for quality, and quality cannot work in that case. Quality cannot work, people don't take interest. And system is constituted by persons, by personal, and not by material. Material is a part of system, personal are a part of system. So if you just think we have some system certification, I don't think it would work. System is one part, but attitude of individuals is another part. Thus, as I say, quality works. If I refer to quality works, This means we have to take care about quality of every item. I am saying item, not saying goods, because good may contain many items. A building may contain hundreds of items. Facilities may contain many hundreds, same way buildings and others. Depending on what type of work we do, varying from very small work like open drain or sewer line where many items are not available or only few items relate to. Road work, very few items. Same way, building work, industrial works. A long list of items do count. That's meaning quality works. We cannot just say we will do if we do not know what to do, first of all. This means we have to know first what we have to do, and we must have certain basis, and that basis is called designs. And designs means not only structural design, also specification based designs and designs of what to do, how to do. It should be given somewhere in reference. And reference must be understood by everybody, and those who want to do it in field, they must know that. I watch many videos sometimes on YouTube. Those videos are provided by some young engineers. Of course, I appreciate attempt by those engineers who are budding one and who want to disseminate what they know. But one point upsets me. Better avoid something which is not confirmed or not clear. You are interested in video dissemination, it's very good, you should do. But whatever you disseminate in engineering field, it should be reliable. Just for sake of dissemination, if you provide information which is not acceptable, better avoid that. It's not that you do not know. Knowing something superficially and knowing based on experience are two different issues. We have to work in engineering, we have to teach engineering, we have to learn engineering in whole life. Every day we learn something, we teach something, we do something. Engineering is like that. It's not fixed route, but fundamentals are fixed. You cannot say 2 into 2 is equal to 5. It is 4. That's what we have to understand this. Engineering is a world where update is important, knowledge is important, application is important. Only knowledge is not enough if you don't apply that or if cannot be applied. So what I say in my title has I taken quality works, starting with and then going to quality specifications, that is concrete specifications. And concrete specifications also got two meanings, as I usually say, concrete material and concrete state, both. Concrete state applies to every act in life, every material in life, while concrete material specification applies to only concrete material. And I say civil field engineering, civil, another is field, another is engineering. Civil field is open to everyone, whether or not you are retained or you work in civil, otherwise you don't work in civil. Both ways it's open to you. If you don't work in civil engineering field, you use civil engineering. It is you who use civil engineering, irrespective of you require it or don't require it. Everybody uses civil engineering product. You walk on road, you use drain, you use footpath, you use building. Whatever work you do, wherever you do, all over the world, everybody relates to civil engineering. And this is beauty of this field, that it's open to everyone, animals, humans, machines, all. Mechanical work cannot be done if civil engineering work doesn't exist. Same applies to electrical. It's very important point. means it applies to life. Life and life means engineers. As far as life is concerned, engineers exist everywhere. And therefore, we can say systems. Systems of quality and systems otherwise also. When we talk of quality system, I can say it's better to talk of system. System means whatever system we have, quality system is one of those systems. So if your system in engineering is good, you can say system of engineering or engineering system, quality system already is covered in that. When we talk of system, quality system, this means whatever organization we create, we establish for some work, that organization should function smoothly. But we have to keep in mind that organization also constitutes personal or humans, and those humans have varying tendencies, varying attitudes. Those attitudes impact on works. Those attitudes impact on everything. If your attitude is not constant, and if you can change every day your attitude, it impacts on engineering production. We have to train personnel in this regard. We have to teach them what is required to be done, and they have to teach further themselves by doing what they do, by understanding by doing, by learning by doing. That's why AnnexSL, which is a quality system, latest one according to ISO 9001:2015, it contains certain clauses which got a description, how to define and follow it. It should not be fluous or superfluous, it should be according to requirement. And then we have to use contract books like Red, Silver, White, etc., as well as safety related arrangements. And all these points which I covered within this small talk, these of course include designs and construction, without which you can say nothing can move. Design is number one part in engineering, and construction or manufacturing is another part of same engineering. Both together, if clubbed together, means something in engineering. Designs is whole very, you can say wonderful world where you can think on how to do something. How to do something is of course very important, and that's the way we decide how to do something, how to write something, how to draw something, how to think on what's best way of doing that. And design is therefore wonderful part of engineering, and construction is also another wonderful part of engineering, because design is to be transformed into physical world for this mundane production, and that physical work should be much more important than design itself, because design is on papers and that's on computers, but when you do it on walks, on sites and field, that is real one, and which will stay there for many decades to come. In construction particularly, maybe manufacturing is different, short term, but in construction, once it is done, it's done, and it's beyond control. If you want to remove it, you can remove it, but if you remove it, you waste everything, and if you let it continue, means it may pose problems in future, and future problem depends on where you are weak. The construction is that important part. Design may sleep after it is done. It shall go on record due to it's no more required, or it becomes, you can say, as built. That design, working design becomes as built document, as built design, and construction works permanently. So you can say there is a scale. Maybe you consume 1 unit of time, and construction may take 10 units of time, and after a service may take 100 units of time. Therefore, construction is very expandable. Construction must be very careful. Construction of works, designs of works, and service of works are all related. We have to understand difference, time difference. cost difference. And because of time, depreciation also applies. Strength augmentation applies. Deterioration of parts applies. Distressing applies. Or you can say, sometimes, we say, oh, something has entered in plastic stage, something has entered in yield stage, some material has entered the collapse stage, likewise. And to cover all these points, we say we have to devise some contracts, and only contracts can work, or only contracts cannot work. I can't say, it depends. But whatever somebody does, you do your way, or somebody else, you give someone else who's expert on that in terms of contracts. Whatever you do, methods are to be applied. Contractor does it, or you do it yourself, employer does it itself. You may say methods to do some work is very important part, because there can be many methods to do something, but which one is best, only expert can know. And without methods, our personnel cannot do anything. Whatever they do one way, if you ask them to do individually, they will give you many, many ways. But what's professional way, what's best way, team head has to decide, and that method one writes based on, we can say, conference with all input on that methods, means everybody learns something, and this method can be repeated if activity is symmetrical. And then contracts come to play. Disputes, of course, there can be between two parties, because contract means two parties agree on something, and that's the kind of agreement, mutual agreement, which you can say each one authorizes other one for some rights, for some privileges, for some duties, for some deliveries. And then we can see this kind of organization, authorized organization, and based on many communications, coordination forever, during construction and during maintenance or during whatsoever else. So it's a kind of subtopics in this quality talk, and that's why I'm trying to explain what it works for. And we see on projection, Bharat, India speaks, it says, of course, Bharat, India, my country that speaks. I'm proud of that. The Bharat, India speaks. What's wrong with that? It should speak. Bharat is my country. It speaks something, and it tells, get up quality. It's not myself, it's not me alone. I'm saying Bharat, India, which has some problems, of course, observed problems in quality, and everyone knows it. And my country says, get up quality. I'm asking quality. I am quality some person? No. Quality some state? I can't say. I say quality. Of course it is state. Quality is super state, it works. I'm not talking of statutory state, I'm talking of quality system state. Get up quality. Get up quality. Stop sleeping in hours. You are sleeping. Why are you sleeping, my dear quality? You get up. Don't sleep. Stop sleeping in hours. In my country, why are you sleeping? Are you not happy here? Can't you stay here? Can't you work for us? That's my question to quality is. Quality of my friend. You are my friend. Be my friend. Why do you run away? You are my friend because I cannot work in my profession without you. In my profession, engineering profession, I cannot work without you. You know it very well. Why are you sleeping? Why don't you get up? You stop sleeping because you have to be a part of profession. You have to be a part of profession. Without you being a part of profession, nothing can be said, nothing can be done. I have to use you as an engineer. I have to get you as a consumer. I have to sell you as a manufacturer, as a promoter, as an employer. We are friends together for all others. So my dear quality, why you are upset with me? Why you are annoyed Don't be annoyed. Come on, let's take a cup of tea together and move forward with fresh energy. Quality, you cannot leave my country. You cannot leave me. You cannot leave us. Because you are my destiny. And for nation, you are destiny as well. Well, you may say, this is very emotional talk. No, this is rational. Very much rational. Because I am talking reality. If something is absent, something is missing, it's not reason of that thing, it's the reason of ourselves. Ourselves. What do you say? Others may not, but engineers can handle you successfully. I know you are upset because everybody doesn't handle you perfectly, but remember, and you know it very well, my dear quality, that engineers can handle you successfully, but you also know that your requirement is not recommended when engineers are taught, when engineers are a student. Unfortunately, that is because those who devise our syllabi, our program, they themselves do not have any quality standards. Unfortunate that is that those who know nothing, that they decide for professionals what to study. Well, others may not, but engineers can handle it successfully. And because I say engineering continues throughout life study, it's a study throughout life, so you can be our syllabi, you can be our lead throughout life. If I miss something in education, its field, that gives me that opportunity which I can learn more and more. And we know quality has no limits, quantity has limits. Quality can be superb, quality can be normal, quality can be reasonable, or we can say quality can be full quality. This definition depends on ourselves and depends on my friend quality. We require to establish you permanently. We want you keep here permanently as honor of our nation, lead of our nation, crown of our nation, and that's where quality means. We require to establish you permanently in engineering professions and also other walks of life. We always say that we don't have quality, and that's a fact. And we say because we don't have quality, we cannot export our works. That's also true. I'm not talking of only construction quality. This I refer to all goods quality. And if we are good with you, and if you are good with us, we can travel together with our goods, with our emotions, with our leads all over the world and deliver what other people require. So you can say in all walks of life, in other walks of life, you are required. So we can say, we require you, my dear quality, to establish you permanently in engineering professions and also other walks of life. Have active quality performing applications, quality SHE sufficiently, quality engineering approach on working designs, a must, and manufacturing and construction procedures a must. When I say manufacturing and construction procedures, this is very divergent statement because first of all I'm talking of working designs, which is a long process, voluminous process, thousands and thousands of design drawings, design documents are produced, and without which we cannot move any further. And in construction, you can say it's a continuous design, it's a continuous execution, and nobody can be perfect in that because response to works are known only after many decades. But as far as items of manufacturing are concerned, we can see effects immediately, performance effects. But as far as construction is concerned, you cannot say immediately what's the effect. It takes time. We can see distressing effects or hysteresis effects only after a couple of decades. So we can say quality engineering approach on working designs, a must. Manufacturing and construction procedure, a must. A must, can say, continuously to do assessment for working, considering for quality goals in all works. If you say quality goals, this is something very different, very, very different. Goal, when you say quality goal, this means total goal, because quality cannot be separately delivered. It's very much integrated part of goods. You can say quality goals, quality goods. Quality goals means quality goods in all works. Fixed quality in Bharat, India. Come what may, no excuse for concessions. No concessions can be granted to anyone. You have to fix quality, or you can say quality has to fix us. Unfortunately, quality is not a being, it's just a state of imagination, state of material working, and that's why we have to speak to ourselves. Or I can say we have quality in ourselves. Everyone has certain degree of quality in oneself, and we have to talk to oneself and fix oneself. Or we can say fixed quality in Bharat, India. Come what may, no excuse for concessions. Why should I demand concessions? What for? I want to comply with quality, and that is where determination is. Every engineer is taught that, if not in university, in field itself. Every engineer science that also. The work has been certified according to specifications or quality. But is that certificate false? Yes, it is. I cannot say 100% false, but quality system, as far as quality is concerned, that care has not been taken. I can say, yes, we fail. So fix the quality in Bharat, India, it's my country. Come what may, no excuse for concessions. It's also right. And we can say works quality cannot be compromised, and therefore we do not intend to compromise just in name of fragile existing quality system. Works quality cannot be compromised. Works quality cannot be compromised. Again and again I would say that. And you take it. Whether or not it's their interest is not different, you have to take it. Works quality cannot be compromised, and therefore we do not intend to compromise just in name of fragile existing quality system, and calling it fragile because it is fragile. A little ignorance on this. Your own defined system, your own established system can damage yourself. Little ignorance. It's like just nail it, or just nail it on this, and on your screen you just nail it. It may impact working of screen. Same way, if you nail your system somewhere, fragility comes onto that. If you don't follow it, you don't improve it, it starts fragile system, fragile response, and we can say quality system becomes fragile. Compliance, formality, and excuse is no. Quality system may fail. If you cannot say we don't follow it, we comply it, or in that don't do it, no excuse. Quality system may fail, certainly, but works quality must perform, or quality works must be delivered. What does it mean? This means we cannot rely exclusively on quality system for works delivery, but on can say quality must perform. We rely on performance of works, performance to requirement, and that delivery is made. So which one is important, quality system or quality works? Quality works, if are done, which is adhered to. Quality works we adhere to. System is automatically adhered to. It remains functioning. So for smooth functioning of quality system, we have to maintain quality works, which is a very important part. But it happens or doesn't happen. We have to see it doesn't happen correctly in entire scenario in ours, Bharat, India. That's what I'm very serious about. Red lines to be resolved, and that is very, very important point. What question is, can we know and apply quality standards complied with other nations in various other countries? And that's point we have discussed many times, and these points cannot go out of discussion any time. Also require this when we say engineers detailed deliberations must. Engineers detailed deliberation must. So many questions we are just foregoing. Is what's main point that impacts on quality? What's main point, you might say, as an intelligent person, as a professional, or as a common person? And I say information must be brought to those personnel who require it and must be provided in right time or right requirement and quite rightly, duly coordinated. And then dissemination of engineering information about quality requirements and how to transform using method statements. Very, very important points. We can say information must be brought. Information must be brought. That's why I say information must be brought to those personnel who require it. Information must be brought to those persons who require it, and it must be provided in right time. Right time means time when it's required here, right time, not I give 10 days in advance or I give you after you do work, means that is nonsense. It must be provided at right time, or right requirement, and quite rightly, duly coordinated. Duly coordinated has got greater meaning in this sentence, in this point, and then followed up by dissemination of engineering information about quality requirements and how to transform using method statement. When you see, every work depends on information. Every work depends on information. Whatever information you have to give in form of drawing, in form of detailed drawing, like plans, elevations, sections, notings on that, or giving some specific notings, and also instructing sometimes what else they have to do in the way of typical statements or symmetrical statements, or you may say some instructions which are very common and some may be very specific. These are universally accepted facts that information must be made available. Those who work on sites in construction, they are more tuned to physical activities, and of course they get these drawings. Depends on intention of those, what concentration degree they apply onto these documents, and you can't expect them to be very efficient because of various reasons. It doesn't mean that they do not know it, but factor of fatigue, factor of you can say hard work, or you can say physical actions on site. They may sometimes miss something, it happens, or concentration can become point there. But if they have right information in right time, or there is some direction on front lines, they care about this, they care about that. Information must be available at right time. And as I said, you cannot say before 15 days I gave you this. If that work is done today, that person has to instruct artisans or craftspersons. On which day? 10 days before or on that day? And because it's work like that, everything cannot be given in writing, that's true, but some very specific technical part has to be given in writing. And they instructed particularly they will check this document. And that's what's important is. If information is given right at the right time and to correct requirement, and that person who takes care of his charge on site, maybe charge hand by foreman, that person, if reads information, if is understood, that person can apply that. And if applied properly, you can say, that's what is quality. That's what's required. And here point is coordination, duly coordinated. Who coordinates it? I always say coordination is very important, very significant part of construction engineering and design engineering. Maybe designers can do it. They are well educated people, experts in their field, respective fields. But those who are on field, on physical work, or you can say those who are related to site works, you cannot expect them intellectually to that level of freedom, because they are adversely impacted by working conditions. They have to do physically hard work, not exclusively mentally. Physically, they have to handle front workers, front machines, and they have to handle many other parts in works, activities in works. And you can say every point, every aspect that that person looks into can do better. And we have to bring that person to that level that coordination happens, and that coordination, maybe you are support for coordination. That coordination means very complex work. It's in fact technical oriented work. Technicalities must be taken into one page, and whatever missing or what superfluous is to be studied. If something is missing, technically generally happens, technical points are missing, and those points are in fact very important to be studied. If we can do that, it's good. One's a fine, one can do that. Missing points can be brought into action or can be checked out. What's missing, why is missing, why is available, it's available or not available, and if it's not available, that information must be worked out. Whatever way we can say, I don't find way that missing information must be checked in, technically decided, who is competent for that, by whom, that person, and that blank is to be filled. And that's what I'm saying, information must be available, and that blank works then. If they may be blank or maybe certain confirmation like clarification, or it may be something that why this is like this, it's not like that, should be that way. So what I'm saying is duly coordinated. Coordination, I always stress in this talk. Otherwise also, Technical point is one, but coordination is another point which involves all technicalities and from all disciplines, whatever it be involved in that project. This coordination is not, a formal subject. It's not a formal engineering, but it's engineering within engineering in every engineering, overlapping subjects, overlapping fields. Coordination cannot be defined in very simple way. Somebody can define coordination means, yes, you can define coordination. There are many ways. Only definition is whatever applies to work should gather at one place at time of work. Whatever information one thinks is required or is decisive in that way, or one what is required knows it, and if collected, if these informations are collected and applied, it's called coordination. And it is very much true. Generally, activities which you do in civil construction live forever. Forever means long life, 100 years, 50 years, minimum 30 years you can say, and maximum no limit. Signals falling again, I don't know how many changes in signals and frames. I don't know why no quality in framing and in signals. So why say construction field is only one in this world which has long journey after it is delivered. During delivery, during manufacturing, it's not that long journey, and during design also, it's not that long journey. Design time, construction time, and its serving time may range into 1:4 maximum is to 20, 30, 40, like that. So this scale of time is entirely different. It depends. I don't accept too fast work also, because civil construction, of course it can be mechanized, but every work cannot be mechanized. Every work cannot be mechanized. That is also true. So we have to deliberate on such issues, that we should try to become coordinators on every act. Coordination engineering, of course, it is very much centralized engineering, and everybody cannot coordinate if one does not have concept of work, concept of every activity, concept of whole project. Having different concepts at different stages, you can say there can be levels of coordination, and those levels are not sometimes easy, because coordination means interdisciplinary study. Interdisciplinary study, which of course requires that one should have understandable knowledge of other subjects, and if don't have, then you can get that knowledge from documents, from drawings. It's not mathematical requirement, it's not theory requirement, it's just reference that this discipline requires this and this discipline requires that. And can I understand that? And if I doubt, then we can raise questions. Automatically, coordination in starting is really unknown, but once you start it, of course, requirement is that one has to immerse. One has to immerse into that activity, and that immersion for sure is very, very important, and that immersion cannot be avoided. And if you don't immerse, and that's also true, that you cannot coordinate successfully. Immersion gives a success, and that success is really wonderful if you can do it. And if you cannot do it, then I can't say it is wonderful. Of course, I try to always talk of coordination, and maybe some people start thinking that because he was a coordinator, he only talks of that. No, I was not a coordinator. I was forced to become coordinator. In fact, that's also true. We can say that's also true, and it's therefore very sometimes interesting. We know how we can do this. Let's try to find something on coordination engineering, and let us say something. I'm getting some information here. Let's say one point is engineering coordination. I'm checking on sites. This is let me see what it says. Something engineering coordination. There's one page. Effective engineering coordination for successful project development. Effective coordination between design, engineering desk and on-site execution is of utmost importance to ensure successful construction or whatever project. I'm just trying to show you this page just for your reference. Let me take print out of this and show you something, though it's not recordable, but just to know how people think about, and that is very important point. In fact, how people think about, just to know people's thought. I'll try to open some sites on this issue. Let's say this one site we opened, and it says engineering coordination. This is I think SGUR, SGURR, SGUR engineering, SGUR energy engineering coordination, and it is engineering coordination, as you can see here. Says effective engineering coordination for successful project development. Search is sgenergy.com. Well, construction monitoring, and here now it says effective coordination between design, engineering desk and on-site execution is of utmost importance to ensure successful construction of solar PV projects. It says that there can be effective coordination between design, engineering desk and on-site execution is of utmost importance to ensure successful construction of solar projects, whatever project, it doesn't matter. Now what it says is project, sorry, my page is missing. So here is what we say. Now there can be disruption at whatever stage of project without effective coordination. So it becomes necessary for developers to get constant assistance to reduce costs and delays at site. To resolve these issues, we assist in project by identifying quick remedial actions and rectifying site issues to avoid construction delays. So this is project coordination. What they want to do services. So I'm not interested in that. Our services, what services they give, let us see that. That's simple. Means there's a service of coordination, in fact. For effective engineering coordination, our site team ensures close monitoring of project documents at site and assist developer to maintain design coordination, let us say daily coordination between site team and in-house teams to get regular updates from EPC. Change management, our team conducts joint inspection with EPC contractors on site to understand coordination and implementation challenges. Revision management, ensuring updated copy of drawing is available with contractor staff for execution. Avoiding reworks, our continuous monitoring ensures use of latest drawing revision by generating non-conformity reports. Observations report for immediate rectification at site and avoiding rework. It's a very important point, in fact. So their mind. So I think that page over. I think so. Required contents are over. So I close this page. Not important for me that much. I go back to my site again and find another point here. Which one is that? This was now I go to PDF Technical Coordination Engineering Practice. This is researchgate.net. Let me see what's that. Researchgate.net. What it says says Technical Coordination Engineering Practice. What does it mean? Let us say I'm not downloading the full text, I'm downloading it. That's what it says. My God, the joining and not joining is not important for me. I think they're just wasting time. I'm not able to join. I know. So it says an empirical. What it says? Let me see. Let me just. This is only small writing. Let us see what it says. I print this one. It's only for your information. It's not something useful. It's not useful in that way. Just to let you know how does coordination matters, and that's important. How does it matter? It's taking time for preview, but no issue. It should work, and I think it's coming out. You'll see in a moment. It's coming out, and I will read it. What is that? Oh, come on. I'm not waiting. Why should we waste time? It's come, I think. Technical coordination is come. And it is technical coordination. I should come now. Technical coordination is a few pages only. So we can say technical coordination in engineering practice. What it says engineering practice, technical coordination. And let me see, I just blew it down. Says it's by some writers, that is technical coordination in engineering practice, James Trevelyan, School of Mechanical Engineering, University of Western Australia. Or let's see what it says. What says this guy? Let's see what this gentleman says. It has gone actually. Yes. Now it says an empirical. Let us see. That's why I believe it. An empirical ethnographic survey of engineers, an empirical ethnographical, this is an empirical ethnographic survey of engineers using interviews and field observations in Australia provides evidence that coordinating technical work of other people by gaining their willing cooperation is a major aspect of engineering practice. I read it again, it's good. An empirical ethnographic survey of engineers using interviews and field observations in Australia provides evidence that coordinating technical work of other people by gaining their willing cooperation is a major aspect of engineering practice. Technical coordination in context of this study means working with and influencing other people so they consciously perform necessary work. They conscientiously perform necessary work to a mutually agreed schedule. While coordination seems to be non-technical, analysis provides evidence supporting critical importance of technical expertise. While coordination seems to be non-technical, analysis provides evidence supporting critical importance of technical expertise. So what it says, my God, I'm finding some difficulty in reading this really. Some difficulty in reading this page. Where is gone? That's the problem. It's gone. I think I was on the right page before. Finding the problem. Okay. While coordination seems to be non-technical, analysis provides evidence supporting critical importance of technical expertise. Coordination usually involves one-on-one relationship with superiors, clients, peers, subordinates, and outsiders. Coordinating work of other people seems to be important from start of engineering career. You see, start of engineering career is important. Means coordination starts from very budding career, you can say. When you are budding engineer, you have to start coordination from that stage. This means this is fundamental engineering, you can say that. Engineering education only provides limited informal coordination skill development. And current accreditation criteria may not reflect this aspect of engineering. This paper suggests ways in which students can learn coordination and describes some of authors' experiences in applying this research. So we have a good paper, in fact, and keywords that says coordination, engineering practice, informal leadership. Now it's introduced like this. Unfortunately, there are few reliable reports of research on engineering practice. Very few observations have been reported, for example, on actual work performed by engineers. Very few observations have been reported, for example, on actual work performed by engineers, technical managers, planners, technologists, and technicians. Certain process in engineering practice, such as design and project organization management, have been extensively studied. Yet many other aspects, such as maintenance, have hardly received any attention at all. This is all more surprising given extensive debates and written literature on engineering education. An accurate account of engineering practice could help educators explain relevance of coursework to students, helping to provide appropriate motivation for learning. Such an account may also reveal opportunities to improve curriculum design. Now, this project started as a comparison of engineering practice between South Asia and Australia. First-hand observations of unexpectedly high end-user costs for engineering services such as water supply, electricity, transport, and construction in South Asia promoted questions. Is engineering practice different in South Asia compared with Australia? Same time, companies in Australia reporting significant difficulties and financial losses in maintenance, and attempts to improve maintenance have often been ineffective. Solving these problems requires an understanding of both social and technical issues. A detailed systematic understanding of engineering practice is required. Now, what we say, it says this paper presents initial results from an empirical study to establish a systematic framework to explain engineering practice in at least majority of engineering disciplines. Technical coordination emerged unexpectedly as most prominent aspect of work performed by 55 engineers interviewed so far, and it does not seem to have been mentioned in previous literature. Technical coordination in context of this study means working with and influencing other people so they can consciously perform some necessary work in accordance with a mutually agreed schedule. It is an informal process, unlike project leadership or management, which has formalized written methods. Other aspects, such as design, appear to be much less prominent than expected. This paper reviews relevant literature and presents a cross-section of quotations from interviews before discussing some implications for engineering education. For engineering education. Author also presents some own attempts to create opportunities for students to learn about coordination and develop some basic skills in light of results reported in this paper. Research literature on engineering practice. And this introduction now, let's say introduction before going further. I'm talking about this. It says, where's that page? Sorry, this is there, yeah. Unfortunately, it is introduction I'm going to talk. Unfortunately, I think I'm wrong. It's there. Yes, that's page 7. Yeah, research literature on engineering research literature on engineering practice. What do you mean? What do we mean? Let us say, what do we mean by engineering practice? So distinctions within occupation, distinction between occupational group can introduce arbitrary boundaries. Distinctions within occupational groups can introduce arbitrary boundaries, especially between engineers or professionals and other workers, such as technologists. In our research and our search relevant literature, we have included all engineering disciplines and aspects, including planning and organizations that leads up to ultimate production, whether executed by production workers, technicians, tradespeople, or machines. It's essential to recognize that most engineering involves highly coordinated work by many people with different roles and responsibilities, and success relies on ultimate production being performed correctly. Engineers seldom do hands-on production work, yet they are often held responsible for production and service delivery performed by other people. Performed by other people, production or service delivery workers. We can distinguish different aspects of engineering, being planning, analysis, design, organization, and administration precede final hands-on production or maintenance that results in useful products, solutions, and services. It all are part of engineering practice. There is no clear, distinct dividing line between different aspects. Engineers engage in hands-on work, and technicians are often involved in planning and coordination. Same time, we also be interested in diverse aspects of engineering work. Engineers may refer to some duties as not real engineering work or all that administrative stuff. They even organize social activities. Yet these aspects are still part of picture if we are to understand what engineering is all about. In some, you can say, let's take up to here. In some discourse, engineering has been considered to be purely technical. For example, some presented a comprehensive account of a continuing education and on-job learning for engineers without mentioning any non-technical skills training at all. Many academics and students have pursued engineering practice in terms of technical problem solving. On the other hand, some Cornelian Middleton surveyed personal and professional skills, non-technical skills and knowledge. Even though in introduction they acknowledge that enhanced oil and gas recovery methods, decommissioning and abandonment will have an impact on skills engineers need, acquire and develop. Barley and or provided evidence of prevailing image that separates management from engineering. A person is either a manager or an engineer. Former has little or no technical content in its work, and later has little or no social dimensions to its work. Investigations into loss of Challenger and Columbia space shuttles also noted this dichotomy. However, Research for this paper revealed that engineers were often coordinating work of other people. A recent survey of about 120 research publications revealed two major groups of reports. Investigations of engineering education have simulated about half of reports on engineering practice. Other half has emerged from researchers who have been interested in engineering management. However, vast majority of these results were obtained using presumed lists of engineering tasks, which do not seem to be based on empirical observations. Only a small number of empirical studies can be relied on, mostly using anthropological approaches. Based on qualitative research, several provided field observations and quotations which provide data for triangulating interviews and field studies in this research. None of research studies seem to include a detailed classification of engineering practice or broad enough coverage to attempt to build one. Studies additionally informed by first-hand engineering experience were mainly on design, only one of many aspects of engineering practice. Design carries considerable glamour and status, particularly in high technology and aerospace. It has been studied extensively by many researchers. However, for most of these, their interest lay in design process rather than less glamorous tasks that designers also have to accomplish. One has reviewed recent research and Wiki presented examples of design ethnography. Technical problem solving has also been studied by interviewing engineers, revealing that technical issues seldom drive choice of solution. Presented one of earliest accounts written with benefit of first-hand experience in planning. Interests lie in reflective aspects of professional practice, and it was described engineers inventing a new process, used term technical rationality to describe science-based professionals as technical problem solvers. Science-based professionals as technical problem solvers. According to this model, problem solving is a manipulation of available techniques to achieve chosen ends in base of manageable constraints. Solomon and Holt used an ethnic approach to study mechanical engineering practice with stated aim of revision to engineering education. Bucharley is significant because he was one of the few engineers who has made extensive contributions to literature on engineering practice. Introduced the useful notion of object words, domains in which engineers conceive their designs and explain how they work, analogous to planes of objects described by others. Martin interviewed recent engineering graduates to evaluate how well they thought they were prepared to work in industry. In their collection of studies, Barley and Orr attempted to define technical work, suggested that such work requires understanding and utilization of abstract knowledge, such as mathematics or science acquired through formal education. They acknowledge that many technical workers, particularly technicians and trades workers, acquire their knowledge and skills through through their own experience and by working with more experienced workers, apprentices, rather than through formal education. They also suggested that technical acumen is result of contextual and tacit knowledge. Several social scientists have studied engineering practice to understand place it occupies in society and workplace rather than detail of work itself. Social scientists have acknowledged difficulties in understanding technical work. Engineers continue to play havoc with conventional models of work even though they are prototypical technical workers of high industrialization. One of various barriers for social scientists is technical knowledge, presenting an actual dimension that requires years of practice to fully comprehend. Much of engineering is desk work based on thought processes, whose character is manifest only partially in various pieces of paper that are intermediate products. Some aspects of engineering practice, especially its technical content, resist observation. More recently, some researchers have examined engineering work by men and women to test gender-based models of working roles. Of course, ergonomics and human factors, engineering researchers have studied specific work practices, but focus has predominantly been on specific machine and process operators, namely pilots and air traffic controllers. For example, Reason and Hobbs provided a detailed analysis of errors in aircraft maintenance, yet a detailed description of work seemed to be assumed as it was not described. Wink provided an intriguing study of engineering design in turn that revealed need for extensive coordination to establish working spatial boundaries. Also pointed out how weak our real understanding of engineering and technological work was. We live in an era of paradoxes. On one hand, we are faced with ever-growing array of technological developments that affect communication, work, travel, domestic and leisure activities, and political and ethnic debates. On the other hand, in many ways, we do not understand these technologies. Surprising things that this is true for technological professionals as well as for lay people. Our situation is characterized both by our ignorance of new technologies and by our faith in them. It seems that our knowledge of nature of most engineering practice remains near the state of our appreciation of management in mid-1960, when Mintzberg started research on nature of managerial work. Questions posed then in relation to managers, such as what kind of activities does manager perform, could just as well be asked about engineers and technologists today. On reflection, reason for this gap in research literature might be explained by a relatively small number of people with appropriate research skills and tools, and at the same time enough first-hand experience to understand language and concept of engineering practice. Question is, what do engineers do? What do engineers do? Seems obvious with hindsight. Yet that was not sufficient for this author, who had most of required skills and 20 years of first-hand experience in different fields of engineering. It was apparent contradiction in South Asia, low labor rate with high costs, that resulted in a serious research for explanations. Empirical research, method, analysis, and interpretations. You can say empirical research, method, analysis, and interpretations. Now we are going to discuss further. It says this paper reports initial results from a wider ongoing study of engineering practice. Empirical research followed well-established qualitative research methods used by contemporary social science researchers. Most data came from transcripts of semi-structured interviews performed by authors. Sampling was partly opportunistic and partly purposeful for maximum variation. Ultimate aim is to include engineers in all major disciplines and types of business, namely consulting, private firm, manufacturing, maintenance, operations, sales, etc. With between 3 and 35 years experience, the sampling reflects this aim. Both companies and individuals were approached with this requirement for interviews. Some companies responded with a cross-section of their engineers and others with individuals. 55 engineers agreed to be interviewed so far, with more in mechanical engineering than other disciplines. A list of their graduation disciplines and job descriptions has been provided later in Appendix A. The 3 of interviews subject were female and most had engineering degrees qualification. Now, each interview took between 1 and 2 hours. Open-ended questions encouraged respondent to talk about details of work he or she performed. Follow-up questions elicited more detail and specific examples when respondent generalized. Ethnographic method we used allowed interviews to follow interest of subject rather than sticking to predefined rigid format. Field studies were also part of survey. A limited number of subjects were shadowed with their consent for 1 or 2 days to triangulate interview data. Most interviews were recorded and full transcripts were used for analysis. In cases where recordings were not available, transcript reconstructed from notes was checked by respondent for accuracy. We use standard ethnographic analysis techniques on interview transcripts, field notes, and other reference texts. Similar methods have been used for earlier researchers studying engineering practice. They have published data together with independent field observations, provided extra data to triangulate interviews, providing independent evidence to test analyze. Now, first stage of analysis was to review first 25 interviews transcripts, and this led to a list of approximately 70 different aspects of engineering practice. Substantial engineering work experience was essential to distinguish subtle differences and technical jargon. For example, when an engineer was reviewing technical work performed by others, there was a difference between ensuring that it complied with technical and quality standards and ensuring that it complied with client standards and requirements. In some cases, both checks were performed together. In other cases, there was separate checking. Short, non-discipline specific descriptions appear to be useful way to classify aspects of engineering practice in disparate disciplines. Descriptors provided most of codes for qualitative analysis of interview transcript and other references. Next stage consists of careful coding of first 10 interviews, which revealed need for further 10 additional coding descriptions. For example, planning, maintenance, and developing technical standards. There was little or no supporting evidence for some descriptors, and others had to be merged when it became clear that evidence could not distinguish one from another. For example, separate descriptors for marketing, assisting clients, develop projects, and researching clients' need were merged into a single descriptor in FLESH clients. Now, coordination aspect of engineering practice emerged from interview data unexpectedly. There were 3 questions in interview to explore supervision relationship with superiors, contractors, and subordinates. Initial review of responses led to a single descriptor for supervision and mentoring. There were also a large number of interview responses that referred to interactions with other people that were closely related to supervision, in sense that interview subject was relying on other people to perform some work to provide information. Term coordination seemed more appropriate and general than supervision, as most people were not subordinates of respondent, and instead they were clients, peers, and people in other parts of same organization. Superiors, contractors, and outsiders. These were mostly one-on-one situations, and most references were in response to questions unrelated to supervision. Willing operation also seemed to be important. This became apparent from insightful first-hand comment by C.Y. Connor, engineer responsible for Perth to Calgary pipeline, emphasizing the capacity to obtain willing cooperation of others. Absence of formal authority in most reported interactions led to conclusion that securing willingness cooperation is an important part of coordination. Very large number of references to this coordination descriptor led to a decision to code first 10 interviews, again with a range of descriptors for different kinds of coordination listed in later section. Final stage of analysis. Final stage of analysis consisted of careful review of all remaining transcripts and detailed coding of further 15 interviews using descriptors described about to test for saturation. Saturation in qualitative analysis means that further analysis leads to little or no change in qualitative result. This step yielded only 2 additional descriptors and only slight changes in relative prominence of different aspects of engineering practice, though further detailed evidence continues to emerge from individual quotations. This result helps to confirm that sample size is sufficient to develop a map of engineering practice. Coding of quotations and first-hand observations reported in published literature. together with notes from field observations, provided triangulations for this result and did not reveal any gaps. Finally, descriptors were grouped into categories of engineering practice as follows: managing self and personal career development, coordinate it's important to realize that framework of descriptions, it is important to realize that the framework of descriptions depends on approach taken by investigator. It's well known that classification of kind needed to establish such framework depends on individuals involved in process. No similarly comprehensive framework for engineering practice seems to have been proposed before. Solomon Holt proposed a broad set of 7 descriptors, but a more detailed approach has revealed many important aspects missed in earlier accounts. Real test will be whether framework can be validated or refuted by other researchers. This will take time to establish. Now, coordination engineering practice. It is important to note that some aspects of coordination did not seem to be obvious to interview subjects. If technical coordination, for example, was such an obvious aspect of engineering practice that interview subjects mentioned it explicitly, it might have appeared before in standard descriptions of engineering work. This quotation from an interview with a highly experienced construction engineer showed how he was not necessarily conscious of significance of working with formal authority. Now, interview questions is in square bracket. Let's see what's that. Could we come back to issue of supervision? Most of these interactions seem to involve supervision without direct authority, don't they? Now, let's say it says, okay, initially an engineer will be coordinating work of other people. Later will be given supervision authority over non-engineers. Now, of course, officially there is a line of authority. Engineer can take work to his head engineer. Engineer can take work to his head engineer, who can pass work to head draftsman, who can direct draftees what to do. But you don't want to rely on that because it involves too many people and it is too slow. It's quite unwieldy, and that's why horizontal interactions are essential. That's why engineers spend most time using informal coordination methods, working with people over whom, yes, I see what you mean now, people who they don't have any control over, working along traditional line of authority. This kind of situation illustrates why an engineer spends a lot of time managing up, managing sideways, and managing down all same time. You need lots of subtle negotiations. Resorting to authority is a total waste of time as it only creates resistance and lines of authority may not even exist. Technical coordination can be described as working with and influencing other people so they conscientiously perform some necessary work in accordance with mutual agreed schedule. This usually requires three different phases of interaction. Now, phase 1 and phase 2, let us say. Phase 1 is commissioning work. Commissioning work. Coordinator negotiates an agreement on what has to be done and when it has to be performed. Phase 2, execution of work. Usually it is necessary to be present for some times while work is being done to check that results, perhaps intermediate, turn out as expected. Coordinator should be able to help spot mistakes and misunderstandings early enough for corrections to be made without delaying completion or adding to cost. Some misunderstandings may arise from insufficiently detailed work instructions in first place. Again, when results are unexpected, time and resource limitations or lack of technical understanding may necessitate compromises in requirements. If possible, coordinator needs to be able to foresee technical and other consequences of such compromise. Phase 3, checking work. Final result needs be carefully checked to make sure no further work or rectification is required. Coordinator may not know how to do work or even whether person doing work knows, nor even what final result might look like, and may learn some this through coordination process. In other situations, coordinator may need provide some knowledge and help others develop necessary skills. Willing cooperation increases chances that work will be performed conscientiously with less chance of mistakes and rework. Coordination can seem to be unproductive and time-consuming work, as this short quotation reveals. Tell us what a typical day or working week involves. I would pick one day rather than a typical day. Wednesdays were our meeting day on site, describes example of site meeting. The rest would just be random and okay. Now, a selection of interviews course is one way to illustrate different kinds of coordination work. Explicit references to particular companies or individuals in quotations from the interviews have been changed to preserve anonymity of respondents. Question is, a recently graduated electrical engineer talked about its first assignment working as site engineer and its experiences coordinating electricians with little real authority. On my previous job, I had to work with electricians and technicians as well as tradesmen. They were reporting to me on previous job, not on this job. Maybe 3 to 5, they also reported to other engineers. For example, I had to show them how particular wiring is done. I had to make sure that things are done way we specified in cable schedule and in design diagrams and carried out in timely manner. And is how did you know cabling was supposed to be done? That was easy. You just follow cable diagram. Actually, one of my first tasks was to look at cable schedules and make some modifications. That sort of got me to know how cabling is done. It is not that difficult to pick up. This quotation illustrates one aspect of technical coordination working as site engineer. Cabling was installed by electricians, but engineer was responsible for making sure installation was correct. Electricians probably could read drawings. However, examining each aspect shown on drawings and relating to drawings to actual situation on site helped both engineer and tradespersons pick up details they might have missed by themselves. Engineer needed to know how cabling should be installed, meanings of all symbols used in drawings, documentation standards and methods, and also needed to understand how cabling is part of larger system, so he could understand function performed by cables and hence help to identify mistakes, whatever mistakes in drawings. He had to learn these details on job because neither cable and wiring drawings nor installation techniques were part of degree course. It's probable that he learned much of this from trade skills on site. He continues. And how did you know about how long it should take? How could you tell when they were going slow? Okay, I was doing a very hands-on job when I started. I was working alongside electricians. Working as an electrician like a tradesperson, I know how long it takes to commission a bus station. In a bus station, we have PA systems, communication system, we have 32 stations along busways, and they are all similar. So once you have done one, you know how long each would take. Now, his initial first-hand experience would have involved learning about working methods and techniques from tradespersons. All may have reached their proficiency levels but had learned. He may not have reached their proficiency levels but had learned how long work should take under normal conditions. Following excerpts are shown also show that single phases passes can provide evidence to support several aspects of engineering practice, as in this instance, both coordination and inspection, commissioning, testing. You can also know by quality of their work. They always make mistakes because some of them just cannot be bothered to follow schedules. Some of them don't mark cables correctly. Others do not terminate cables correctly. You can just go on in and find out quality of their work when you just start turning things on. Sometimes you can spend just as much time fixing up their mistakes, but that was all very valuable experience on how you handle this kind of commissioning work because you learn from their mistakes. Spotting mistakes was frequently mentioned in the reports of site engineering experiences. Rectifying mistakes meant discussing problems with tradespersons and arranging for what to be done. You would ask them, hey, you done this task? Have you done this task? They would say, yes, it's fine, it's all done. And then you would go out there and you would find that it is 30% completed There's very little control over electricians because they are unionized and they got paid a lot more than us. They are direct employees, but because they are governed by union guidelines, they are not. They are not really controlled or managed. Quotation number 2. An experienced contracts manager talked about coordinating contractors in his early career. He qualified in several trades, including welding. Now, in essence, your technical knowledge allows you to save money because you can spot mistakes that contractor has made. Yes, it's not only saves money, actually, but you can actually go and talk to contractor while you walk through that paddock and ask, are you really serious about what you are trying to do here? What are you doing? This is wrong. I think you are doing it wrong. Way around. Maybe you should try this. That's important for process. Here he referred to welding work being performed by contractor. Earlier in the same interview, he had shown how revealing aspects of its own knowledge help to build informal respect and authority, reducing need to resort to formal lines of authority. I think that's one of things in whatever contracting relationship is that often we talk about an us and them scenario. And too often it is confrontationalist. And too often it is confrontationalist. One of important issues is to get respect of both parties in discussion. A contractor that succeeds means that me as a client has succeeded. A contractor that succeeds means that me as a client has succeeded. He gets a good result and I get a good result. If he fails, I have generally failed. Really, there's a project work where everybody has not succeeded, that you have actually got a successful project outcome. You're either over budget or behind time. In next passage of finally referred to costs, threshold of pain indicated minimum cost at which contractor would perform work adequately. Living with outcome implied being able to predict technical consequences caused by accepting compromises in work performed by contractor. So issue is if you can both respect each other and you can both talk at the same level technically, and then commercially you can help each other get the result. You hit that threshold of pain where it is not enough for it, but it's more expensive for you. You can both live with outcome. That's a good result. Now quotation is, an experienced mechanical project engineer coordinated production personnel who were also working on other jobs. This quote illustrates why continuing interaction is required. Production staff have skills that can improve outcome when effectively combined with engineers' knowledge. And different things happen, so you can always gain knowledge from people on shop floor actually doing that. Skilled tradespersons and all sorts of other people, they might think of a better way of doing it. So that's where you got to interact. Otherwise, you would never be there to learn, would you? Now, quotation 4. A recently graduated mechanical engineer took over responsibility for installation of a product treatment facility. In unexpected absence of project manager, he had to organize work of each contributor in the right sequence to achieve required result. In that role, I was commissioning engineer, so I had responsibility for builders, electrical engineer, mechanical inspector, and regional operating staff. During commissioning, we had 48 hours window in which to get it working. What a rush! I loved that job. I certainly had to have a good rapport with all people I was interacting with. Now, an experienced civil engineer talked about what recently graduated engineers learn in first few years of their career, which in this instance is site engineering. Now, let us start at the beginning of a young engineer's career. In a construction company, first function of an engineer would take on is working as a site engineer. Somebody else, some other engineers have worked out about how job is going to be done. All instructions be passed to site engineers, either verbally or usually in writing as well. The job of site engineer is to collect all information and instruct foremen on what has to be done and when, ensuring all tools foreman requires are delivered to site on time and in right sequence. Then he has to go around and see what's coming out of other end. Quality of works, whether it's being done efficiently and safely, which creates feedback loop to assess if planning in was successful and make necessary corrections. Collecting information usually requires coordinating other people to provide it. Collecting information usually required coordinating other people to provide it. Ensuring tools and equipment delivery required coordinating hiring companies and other company staff and possibly transporters or truck drivers. If results of site work did not turn out as expected, we have had to coordinate contractors to perform reworks and corrections. It says collecting information usually required coordinating other people to provide it. Ensuring tools and equipment delivery required coordinating hiring companies and other company staff and possibly transporters or truck drivers. If results of site work did not turn out as expected, we have had to coordinate contractors to perform work coordination. What are kinds of mistakes made by young and inexperienced engineers? Most common mistakes is inadequate preparation, not having read specifications fully, not having looked at drawings in every detail, not having read site plan to figure out what is needed on daily or weekly basis. Job of site engineer is to make sure that everything that is needed arrives on site at appropriate time. You can't bring in everything at once because there shall not be enough space to store it and protect it from weather. And you cannot store wet concrete. Forgetting to order enough nails can be a fatal mistake for a carpenter site. Here we got some insight into level of technical skills and knowledge needed for effective site engineering coordination. In following excerpts, we see where this course could be put to test. The next kind of typical mistake is not having enough confidence in checking roll. It takes a lot of energy, time in checking drawings and work, specifications and a lot of technical knowledge to know whether job has been done right. And you have to have confidence to assert that job has not been done correctly and request further tests. Sometimes you can be wrong. Tests may show that job was done sufficiently in first place. You have to have sufficient strength to character to wear with these mistakes and learn them from. Construction job really consists of bringing in hundreds, thousands, tens of thousands of parts and assembling them in right sequence. You have to be able to understand. You have to be able to understand materials and how to assemble them correctly. To do construction work, you don't have to know how to make all parts. Now discussion, let us see. Even though only a small number of interview quotations have been included in this paper, they illustrate factors. First, even recently graduated engineers reported significant coordination, often without formal authority, conferred by an organization structure. Most respondents mentioned importance of maintaining good working relationship, and some commented directly on counterproductive results of resorting to authoritarian or confrontational relationships. This aspect of engineering practice does not seem to have been mentioned in well-known texts of engineering management, except in context of cross-functional teams. Importance of communication in engineering practice was frequently emphasized in their recent study of graduate perceptions on their preparation for industrial work. Martin commented on interactions between technicians, technical communication and teamwork skills, and importance of interpersonal skills. However, they did not show any how these are linked to practice. Although coordination is useful in team situations, most reports of coordination in interviews did not refer to teamwork. A good example is coordination with clients, either directly or through staff employed by client. Another factor is better switch. Another factor is importance of technical expertise in coordination, illustrated in some of quotations reported. Technical knowledge can be a significant factor that confers informal authority in working relationships, which can result in a currency to trade for influence. Spotting mistakes in drawings and specifications is an important aspect of site engineering. This draws on technical expertise. Engineering practice is commonly separated into real engineering or hard technical work and soft skills, including communication. Results of this study tends to support a different view that coordinating people and gaining their willing cooperation is most prominent aspect of engineering practice for many but not all engineers, and that this relies on technical knowledge and expertise as much as interpersonal communication skills. A different observer might have considered the coordination to be a part of management or even project management. Several interviews with engineers working as project managers yielded more references to coordination than other interviews. However, However, project management is a formal process that includes planning, resources, allocation, budget and financial control, progress assessment, reporting and measurement. Coordination, on the other hand, is an informal, interpersonal process. Some aspects listed as part of coordination group below, such as delegating technical work, could often be considered part of management. Management involves coordination, yet interviews with engineers who did not hold management position yielded many references to coordination. Qualitative analysis software provides an easy method to count interview references to codes. In our case, to description, that are specific aspects of engineering practice. This does not imply a corresponding proportion of work time, but thus provide strong evidence for relative prominence of coordination in engineering practice. Now this figure shows average number of interviews references. Well, it's coordinating people, engineering process, technical review, technical creative, self and career development, business development, procurement, financial, human resources. Now it says this figure, average percentage of references in each interview. The engineering work descriptors in designated the categories. Thin line at end of each bar represents extents of variability between interviews from one standard deviation of percentage less than average up to one standard deviation more than average. So 10 different categories of engineering practice listed earlier. Coordinating people dominates the graph following by engineering process. So that is coordination here, then engineering, then technical review, then technical creative, then self-conscious development, career development, and business development, procurement, financial, human resources, etc. Says coordinating people dominates the graph followed by engineering process, which includes project and operation management, change management. Proportions of interview references to these aspects has least variation between interviews. Says previous questions, previous quotations illustrate several different aspects of coordination, site engineering, contractors, in-house technicians, coordination. Descriptors include. Now what's that? Let's say working with and coordinating other people inside organization, gaining their willing cooperation, mentoring, coordination clients and their staff gaining their cooperation, supervision, coordination and monitoring works by contractors, site engineering, supervision and monitoring technical work in progress, coordinating other outsiders and external agencies gaining their cooperation, advocating, persuading, compromising, putting one's point of view, in meeting one-on-one encounters or preparing persuasion documents, supervising staff, line management descriptor, delegating technical work, delegating supervision of technical work, reporting progress to supervisors, peers, and team building and leading, networking to support coordination, and reverse monitoring, providing informal help for more senior or more experienced people, reviewing, developing standard procedure and policies for organization, organizing social and recreational activities. In 25 interviews, coded so far, 7.5% all interview references were about coordinating people inside organization. This was most commonly referred reference single aspect of engineering practice in our study. This was followed by managing projects 4.2%, designs 3.5%, following procedures 3.5%, and coordinating client 3.2%. One must be careful. One must be careful not to place too much significance on numerical results. Numerical values can be strongly influenced by way interviews and analysis conducted. We are planning to conduct many more interviews to continue this investigation of engineering practice, particularly with technologists and planners as well as more engineers. And it's possible that this will lead to further refinement of framework used for analysis. Level of interview analysis has been more detailed than reported in this paper. Coding scheme includes many aspects of technical knowledge used in engineering practice. We also undertake some quantitative surveys to enable us to estimate time allocated to different aspects of engineering practices. As to now conclusion. What's conclusion is? Impacts of engineering implications for engineering education. Engineering education is traditionally viewed as necessarily technical with some management or soft skills content. Prevailing social view reflects this and sees engineering as a technical discipline, applied science, or specialized technical problem solving. Science, Technology and Society, STS. Science, Technology and Society movement has argued that engineering is both a technical and social discipline. Technical and social discipline because of its inevitable interactions with society in which it operates. Following this thesis, Ravison argued that engineers should acquire communication skills through project examining social acceptability of technology. They saw communication competence in terms of need, ensure or secure social consensus for innovation. However, evidence from this research suggested that interactions within engineering organizations and with client and contractors are much more prominent in engineering practice, more than 20% interview references than in interactions with other social actors, average 0.5% of interview references. While social context of engineering imposes constraints that largely define way that engineering problems are solved. Interactions at individual levels are largely within immediate work context rather than external. Data from this study shows that coordination is a prominent aspect in work of engineers even at start of their career. Engineers we interviewed devoted little of their attention to hands-on technical work. It was largely performed by other people, average 0.12% of interview substances. Some observers might have included programming as hands-on work. In few cases, this was a small but significant component of technical work. Evidence showed that engineering work was coordinated and driven by engineers, but end results were delivered through hands of other people. Link between engineers and ultimate production and service delivery was a complex series of social interaction. The strength of evidence presented here leads one to conclude that engineering needs be treated as technical and social discipline at the same time. STS advocates have argued this on basis that engineering cannot be separated from social, political, and economical context in which it operates. However, prominence of coordination strongly suggests that engineering relies on social process at microscopic level of individual interactions between people. Many of difficulties reported by young engineers entering industries seem to arise from unexpected prominence of social interactions. Engineering educators have relied strongly on accreditation criteria such as ABET engineering outcomes and engineers' Australia genetic attributes to provide guidance in course design. Provided a detailed discussion, none mentioned coordination or gaining willing cooperation specifically. While one might interpret teamwork to mean same thing, and there are obvious parallels, working in teams is a different experience. Most coordination reported in interview data occurs outside context of particular team. There is no doubt that effective communication is required to win willing cooperation, and this probably explains why accreditation criteria and job advertisements place strong emphasis on communication skills. However, defining communication skills is an educational objective can lead to many different interpretations that are not relevant for coordination. For example, communication skills could be interpreted as ability to make technical presentation. However, a visually attractive PowerPoint presentation shall probably not be very helpful in arranging well-timed concrete deliveries at construction site. Therefore, we can raise legitimate questions on whether current engineering accreditation criteria mentioning teamwork and communication skills are promoting effective acquisition of coordination skills in engineering students. Effective coordination relies on hierarchy of many other fundamental technical and interpersonal skills, such as preparing instructions for technical work, drawings, written specifications, inspecting and checking technical work, predicting the consequences of technical changes, interpersonal verbal and non-verbal communications, written communications, verbal and visual, selecting appropriate communication strategies, negotiations, mentoring, and informal leadership. Coordination also relies on an accurate appreciation of both individual and shared technical knowledge, domains, and ways to represent technical knowledge in working context. Author is not aware of any engineering course with formal development of coordination skills. While it's not the main aim of this paper to explore formal ways to build effective coordination skills, it might be helpful to review some existing opportunities for informal skill development. Even though there seems to be no specific instruction, and engineering education can provide opportunities for students to learn about coordination and also for informal coordination skill practice. It is worth posing questions as to whether less able engineering students, especially least able who manage to pass course, have acquired basic skills in coordination through necessity. Securing willing cooperation of more able students will help them complete assigned coursework. This could perhaps give them a head start in what seems to be dominant aspect of engineering practice. One could speculate that paradoxically, most able students intellectually may well have had least chance to develop effective coordination skills in a typical engineering course. An engineering internship could provide opportunities for students to appreciate the importance of coordination by observing experienced engineers. However, in absence of understanding necessity and significance of coordination, an engineering student could be just as likely to see it as merely administration and not real engineering work. Students can only begin to observe coordination if they have some idea of what to expect beforehand. Engineering faculty could advocate that students develop coordination skills through active participation in community organizations, both on campus organizations such as student clubs and off-campus groups such as sports or community organizations can provide plenty of opportunities. Faculty staff could also help to counter a common misperception by students, especially those with work experience, that engineer can use authority to obtain effective cooperation in engineering practice. This research has been accompanied by a natural desire to use results to improve learning outcomes, particularly in team projects. Uneven participation of team members is often reported by students, and this may reflect weakness in coordination skills. Since 2001, author has presented a second and third year course in which teams of students from both courses undertake semester-long mechatronics projects, mostly requiring both hardware and software development. Each team typically had 2/3 year students, notionally leading 2 second year students. Even with extensive teamwork skills development, many groups have had very uneven levels of student participation. It became evident in face-to-face assessments and individually written experience reports. Following this research, author introduced a team review session in which students evaluated team performance on approximately 40 indicators. Most common issue raised by students was failure of one or more team members to deliver promised work on time or even at all. This was closely followed by team members reporting that their assigned work is completed when it actually needs further work. Some students complained at amount of time needed help other students achieve technical work needed for project to succeed. In review session, we students and author worked through and eliminated many possible reasons such as motivation, other communications, and insufficient time to we ended up concluding that most plausible explanation is that team members did not know how to do tasks they undertook to complete. We then pose question, how would you know whether this is the case? And the students suggested asking each team member whether they felt capable of performing this task and then confessed that they would be unlikely to admit their own lack of competence. Some suggested requiring each team member to undertake a performing test and then realize how unpleasant this could be. Surprisingly, none of students suggested sitting with respective team members to watch them undertake tasks and help if necessary. In terms of model for coordination presented in this paper, second and third phases of coordination were conspicuously missing. Once this had been pointed out, there was some evidence of improvement in team dynamics, judging from difference in team performance before and after this review session, but more systematic observations shall be required to draw definite conclusions. Students also visited the major mechatronic engineering installation as part of course, partly as a result of this research and also to help acquire additional research data. A semi-structured interview was incorporated with one of engineers associated with installation work. Students conducted interview using a subset of research questionnaire and cooperated to prepare an interview transcript. Students also prepared a report on what they learned about engineering practice from their own project experiences. Site visit and interview on each 30% of course assessment was based. Reports suggested that most of students had understood significance and importance of coordination work that seemed to be so frustrating and time consuming in their team project experiences. Given prominence of coordination in engineering practice, a more systematic approach to coordination skill development is probably essential for engineering education. This cannot happen without a more accurate view of engineering practice. Given predominant view of present generation of academics and students that engineering practice is technical problem solving, it shall take time for a more accurate view of engineering practice to emerge. This can only happen through sustained research. It's surprising that so little research has been conducted even with field of engineering education to better understand work that we are preparing students to be able to perform. Such research could have several benefits beyond improving our understanding of engineering practice. First, it is possible that serious research attention to social dimensions of engineering practice could lead to practical improvements in ways to organize engineering practice. Second, academics performing this research would be well qualified to introduce formal methods for students to acquire coordination skills as part of engineering education. Indeed, with such a cadre of researchers, it shall be difficult for academics predominantly based in engineering science to achieve this. Third, engineering students assisting this research effort shall learn systematic techniques to observe human behavior on which results of much engineering practice depends. Fourth, detailed knowledge of engineering practice through systematic research provides greater credibility for teaching academics to explain relevance of course material to students. I think then there are only references in this, and this is appendix what says background and occupations of engineers interview. What's that? Let's see what is that. It's interesting also. In this electrical process control division manager, mechanical, of course years of experience long, plant general manager, likewise various designations are there. So I don't think it's use of time to Appendix B, interview questions. Let us see this importance of one page, I think. It's important is interview, this is Appendix B says, interview includes basic demographic questions on individual and estimates of number of engineers and other employees in organization, some warm-up qualitative questions on individuals' education, experience, precede main interview questions below. Not all questions were asked in every interview, sometimes because of time constraints and sometimes because they had already been answered in earlier responses. Say example is, please tell us about your career so far. Please tell us about your current position, your role here and your responsibilities. Tell us about technical aspects of your duties and your current position. Tell us about planning or estimation work that you have to do. Tell us about any marketing or sales promotion work that you do. Tell us about any fixed procedure. Tell us about some fixed procedures that you are expected to follow. So purchasing, design, change control, defect reporting. Who do you report to and for what? Do you have to report to more than one person, and if so, for what? Who also reports that to you? Tell us about any supervision responsibilities you have from time to time. Tell us about work that you do with drawings, either reading them or creating them. Which software tools do you use? CAD packages, Microsoft Vision. Tell us about any subcontracts responsibilities. That work that you are responsible for, that's actually performed by subcontractors. Tell us about any financial responsibilities that you have in your position. Tell us what you enjoy about your work. Tell us how do you decide what to do each day. How much does your boss decide for you? Tell us how you obtained this job. How did you apply and what the selection process involved. Tell us about your job security. Tell us about guarantee of continuing employment you have been given. Tell us about most demanding aspect of your role here, when you have to work hardest. Which part of your job makes you work harder? Tell us what your typical working days or week involves. How much time in relative terms is spent on each aspect? How does your pay compare with people in other firms or industries at your level? Tell us what you know about your organization's performance. How do you get to know about this? How much do you other employees know and how do they get to hear about it? Can you give us a broad indication of price of services or products your organization provides or makes? Construction cost levels, price for product, hourly rates. How do you calculate your labor cost? What are principal components of your labor cost? What are lasting effects of your work, contribution which remain after you leave? Tell us how your performance is evaluated here. Tell us about important aspects of your personal performance and job. Tell us some of new things you have learned that are related to your job in last 6 months or so. Tell us about conferences, workshops, seminars, training courses or formal education you have attended to in the last 2 years including commercial trade shows, product presentations. Tell us if who provided these opportunities, employers, self, others. Tell us about courses that you have attended to on non-technical skills such as supervision skills, conflict resolution, mediation, face-to-face communication skills, etc. Tell us if who provided these opportunities, employer, self, other. Do you regularly use new skills for which you received training on this job? Tell us how your company or employer organizes teams or small work groups. Which levels of employees work in team? Tell us how you got to choose people you work with, and about how appointments or recruitment activities you participated. Tell us about current job market in your area. If his job terminated tomorrow for whatever reason, where would you start looking for a new job? Tell us about your role in training other people. Tell us about your contribution and how you evaluate their needs and progress. Tell us about any new products or whatever new products or services you have heard or learned about in last 1 year or so. Tell us how you first heard of them and whether you have actually tried using them. Tell us about engineering products or services that you buy in sense that you are main person who decides or recommends who or where to buy products or services from. Sorry. Tell us how you evaluate these products or services. How you decide which is best. Tell us how you evaluate costs and benefits of each product or service. Tell us who you think you are working for, your clients. How do you know what to ask you for? To what extent are they aware of engineering issues? How do they know? How do they constrain your work? What kind of budget or financial limits do they set? What else do you or client turn to for advice or similar engineering products or services? Who are your competitors? How do you rate their services in relation to yours? Tell us about occasions in which your clients have required you to update your working knowledge or introduce you to new techniques. Does your salary depend on how well your company organization is performing? Roughly, what proportion of your pay depends on this? How do you participate in decisions that affect ways your work is conducted? Tell us about your distinctions between employees at different levels. Do you take meals with employees at different levels? Tell us about special systems or techniques that you regularly use in your work, namely value engineering, safety case, hazard analysis, risk management, quantitative risk analysis, total quality management, critical path project management, sigma quality control, Toguchi methods, RAMs, reliability, availability, maintenance, safety, reliability centered maintenance. Tell us about information resources, You use text, libraries, internet, in-house resources, commercial resources. Where did you reference books come from, if mentioned? Tell us about special tools or techniques that you use in that would not be available or would be expensive to buy if you set up your own business or moved to another company that did not have them. Tell us about checking procedures in your company that help to prevent you from making major mistakes. Tell us what you think is important for promotion or pay increase here. How else does your boss show its appreciation? Tell us how your work affects or could affect environment. Tell us about how environment constraints or laws affect your work. Tell us how you see where you and other people work in this kind of organization in this country in relation to ways that other engineering people work in other organizations or countries that your close colleagues have experienced. Tell us if you return to your completed projects sometime later to evaluate client satisfaction sometime after final completion, and what kind of issues have arisen from this 2 years later. Tell us about the impact of your work of dishonest behavior by people. How do you work with them, this human weakness? If you can, please tell us about how you make allowances for this in planning or cost estimates. Do you think in imperial US units, feet, inch, pound or metric units? Why? Because we have missed something interesting. So this was a coordination paper. Of course, it's an interesting one. Well, I like to save it for my. Can I save it? I don't think I can save it. Let me print it out only. Then I think we can save it. I think I should close and let me print it out. When it's possible, I think so. Print it out and save it. And maybe for tomorrow we need something. I must save it. I think I can save it now. That come. Well, this paper was in July 2007, long back. It's of course longer paper. It's not coming out. What's the reason? I don't know. It's not coming out. It's come out. It's come out. So now we can save it. Save as coordination. I can say. You can write anywhere, method statement or let us see. Where I should write it. Let us see, write in. Problem is, you write there in the video set. Generally course. Let's say the facilities, of course, no problem. We'll take in facilities. Let us see coordination. Coordination, okay. And that's it. Let me close it now. I close it now. I close this also. Let me go back with this. I think it's now time for this, let's say. And I can say that I can go back. Put it off, go back now. Let's see which other paper is good for it. Let us see which paper is good for our work. Now, this one now PDF technical coordination. Now, list of engineering coordinators responsible. This was that list of engineering. Where is it? Let's see what says. Engineering coordinator responsibilities and duties, and this is a great sample, presume. I think this is a duty description. But this says support to department director with electrical support, required inputs. What's that? Engineering coordinator responsibilities and duties. Let us see, let us print it out also. The department director with clerical support record inputs and logs, daily and annual preventive maintenance work orders, assist all engineering department personnel along with entire hospital staff and the day, update and maintain engineering department payroll using time and attendances, coordinate with design consultants, engineers, project representatives, statutory deliverable requirement for submission, review design deliverables together with design consultant and engineers to participate in technical issue design clarification, technical design clarification project meetings, and of course coordinate project coordinator team members, develop relations with planning engineer, coordinate with document controllers, assist it's a waste of time. I think I'm wasting time. Let's go to other one here. That is, I take another C. Why coordination key is construction. What why coordination is key in construction? Let's see that. Coordination is key in construction. Coordination is key in construction. How many pages are these? Let us see what it says. So as you can also see, I'm just trying to print this, so you can see also what is that. Now it says here is this page. We have to see that. Why coordination keys construction designs? It is most projects require input of several disciplines to produce a complete set of drawings and specifications needed erect a building. Architecture, civil, structural, mechanical, electrical, and plumbing engineers usually comprise design. Design teams' efforts are poorly coordinated. Drawings on one discipline may not align with another. If such errors make it onto construction drawings, there is a chance that building will end up with a deficiency or a change order. We needed resolve issue. To avoid consequences of this nature, it's imperative that architects and engineers harmonize efforts and ensure that their drawings interface properly. Now, design process starts after a consultation with client, during which project's budget, expected finish date, visual appearance, spatial requirements, functions, programs, and other design objects are addressed. Having established client's expectations, architect gets to work drawings and specifications. The minimum full set of architectural drawings should comprise floor plans, roof plans, elevations, sections, and perspective drawings. Floor plans are vertical orthographic vertical orthographic projections which show a building's room layouts and other physical attributes for each floor. These drawings depict interior walls, doors, windows, appliances, equipment, and others. Roof plan shows a top view of building's roof, including slopes, hips, valleys, parapets, skylights, vents, drains, roofing materials, equipment, and other features. Elevations are horizontal projections that show a building's exterior and sometimes interior as seen from the side. Sections depict a view of building and perspective designs like that. So mechanical, electrical, plumbing designs and maybe other disciplines. Other disciplines I would like to say are there. Other disciplines contribute to overall drawing package include landscapers, civil engineers, communication engineers, acoustics, and specialty consultants, and others whose involvement may be required. Clashing arise with drawing tones align well in another. Column example of clashing in to ensure effective integration within disciplines, right expectations must be laid out before project begins. The architect and engineers must agree on a set of individual deliverables that will facilitate their team coordination. Let's go back to other file. Engineering coordination environment of single coordination engineering. I don't think there's anything specific here. Engineering management. Let us see what it says. What it says, let us see. Engineering management, operational design coordination. It is also a paper, right? I love to say effective engineering management is acknowledged as being fundamental to successful cooperation of organizations, while traditional and contemporary approaches to operational engineering management are of great import significance. This remains a need to make further advancement in this field. Such advances shall enable an increase in competitiveness of an organization by contributing towards delivering quality production, shorter time scale at excellent cost. Okay, same typical. But I'm not finding anything, as you can say, I'm not finding anything very specific in this. So, well, what we have learned is specifically in this, we have to come back to our quality file, and that's where we started with, because which I said didn't so much information must be, as we said, this is part of coordination only. It's a very important part, what should be done, what should not be done. And as I have said that in this case, now you have to give me a few minutes before I can come back. Let me go, it's not 5 minutes, I could be back here to share further common sense talks. Based on today has been a day of coordination talk. Coordination has been very important issue for us in engineering, and that was only reason I tried to get it, because it's very important issue. Coordination in our lives, that matters. And in fact, truly speaking, we have not been able, as I said before also, that coordination is different. Based on my experience, I had stated that in engineering works, coordination is very important part, without which works cannot be done rightly. And if we miss coordination, we miss a lot. Coordination, as said in that paper also, there is no description of coordination in engineering education. In fact, that word of engineering education does not understand what is coordination. There is no subject, there is no topic, there is no degree, or you can say there is nothing as such that can be described as practical aspect of coordination. And therefore we can say that it's of course not direct engineering but combination of engineering. Coordination means combination of engineering. There is no direct engineering branch. It's also true. There is no formal subject, no such as such. No, you cannot find any subject. But we have to realize fact that without coordination, nothing can happen. That's also very important point. Communication and coordination must. Communication and coordination, without which we cannot reach anywhere in engineering. Particularly, coordination means you have to link all branches of engineering involved in one project. There may be whatever number of branches involved. Communication moves parallel to that. Communication is a kind of network that works on coordination, and coordination is a kind of network that works on whole project. Successful coordination means successful engineering, successful construction, and before all that, successful designing. And designers have also to realize worth value of coordination. Coordination, this means all involved on that work have to stand together, have to work together to achieve goal of successful work. It doesn't matter, it may be speech based, or it may be writing based, or it may be video based. It is method only that is important, but as far as coordination is concerned, everything is important. A single point missed in coordination can cause havoc in works. And we know concrete is very important material. In fact, very significant, outstanding material that is required to work everywhere in engineering practices, engineering construction, all over the world. And if we cannot understand this point, this means we do not understand what is engineering. Concrete, as I said before also, it's not only material, but it is state of thinking, a state of every being. Concrete and likewise other materials all cost money, all cost time. And of course, operational values. If we break concrete, it should not be broken. This means it should be quality concrete. If it fails in its performance during operations of our processing system, you know what the result? Havoc. You have to stop that process, you have to stop that plant, which can cost millions and millions of units of currency. This point we have to keep in mind, as I said before also. Engineering works means particularly civil engineering construction, like concrete or foundations or superstructure, whatever else. These are delivered for many decades to come. That's why these materials amount a lot. These require preference over all other one as far as quality compliance is concerned. If my building, which should work for 100 years, if it collapses in 15 years, this means there is a loss of 85 years. Same way, machine can be rehauled. Machine can be warranted out and repaired. But it doesn't apply to building. You have to keep in mind. We have to keep this fact in mind that the repair system does not apply to buildings. To that extent, it can be applied to equipment or machines. Concrete works like human works. One has to live long till time comes to go. Somebody has to live 50 years, 60 years, 70 years, somebody has 100 years. Likewise, concrete is same. But the difference is that we are responsible for this. We have to construct, we have to design, and we are responsible, and we means engineers. Engineers, it's not miracle, I'm not saying it's miracle, it's a requirement. If we ignore quality, we ignore our duty, we ignore our job, or in fact, we ignore our prayer. Prayer means work is prayer. We do work, we do prayer. If I do bad job, which has to work for 50 years or 100 years, and because of my ignorance, if that job works only for 10 years or 15 years, then I can say I must be debited with that responsibility. No credit should be given to me. But you cannot decide it today because we do not know how shall it perform. Only guarantee is that work should be done with quality. It may be foundation work, superstructure work. It may be understanding soil properties, or it may be conducting soil investigation. I'm not referring to civil engineering, but automatically reference comes because it is basics that you have to use soil, you have to use foundations, you have to make foundations. Even if you want to install your equipment, you need foundation. Whatever you have to do in life, you need something somewhere related to civil engineering, construction engineering, design engineering, structural engineering. All these come together one above other. If construction cannot be done, this means design is not available. If design is not available, this means reports are not available. If reports are not available, then soil investigation has been done. So many issues are there, one above other. And we cannot say today I hang this building in air, I'll keep it down when foundation is ready. Or when the foundation, I'll keep it later on when soil investigation. Means this is not possible, this is not done. That's why quality is something that cannot be defined like that. Like I say, it's just a requirement. Requirement. It's not based on education. It's not based on something else, not anything else. It's based on must. You cannot say no. And coordination is support. Coordination is support for that. That point, if you cannot understand, you can understand nothing in this respect. So what I say, for me, again I would say, as I said before, get up quality. Get up quality means get up quality. I said get up quality, get up quality, get up quality, get up quality. No way I can say it right. You can't say that I'll take it later on. I can't say that I will take it later on. Then no concession. I can simply say no concession. No concession for that. Today's we talked of something unexpectedly, which was I didn't plan, but I got this file, so I tried to work on that. Coordination. Of course, I have been in coordination for many years and I know importance of that. Young engineers, they may not understand this, professors may not understand this, and syllabus designers may not understand this, even institutions may not understand this. The reality of life is that it exists. Engineers may not also understand this, because nowadays I think engineers are also interested in designs only. They are not interested in struggle. Engineers, those who have higher degrees like MTech, PhD, they are not interested in site work. Unfortunately, it is that they want to work in engineering but without sites. They don't want to work hard on sites. Unfortunately, it is. Engineering, higher education means you have to be highly responsible. It doesn't mean you have designs only. If this design cannot be converted to physical aspect, you know what is meaning of that. Sometimes you have to be very realistic, and that's what it is. I will not criticize anyone, but I would like to tell everyone that we have to respect engineering means we have to respect quality. And we have to respect quality means we have to respect designs, we have to respect procedures, and all involved coordination, disciplinary coordination as well as interdisciplinary coordination. These points we have to understand very clearly. Otherwise, I think what is meaning of discussion is unclear. We have to be realistic in this regard, and that is what here I am. Of course, something unclearly we discussed. Now I take your leave and see again tomorrow. Thank you very much.